Hello guys, welcome back to the channel again. Today we will solve the 10th question of June Leet Code Challenge. The question is search index position. What we have to do is we have given a target value and a sorted array. We have to check that if target value exists, we have to return that index, and if does not exist, where the target value can be fitted, we have to return that index. So suppose we take this as an example. Here we have this as a target value and this as the array. Now what we have to do is we have to find this target value if it exists. If it does not exist, where we can put this value. So for this we will use a iterator. We will start iterating from zeroth index, the index which is which is greater than or equals to 7. The condition where the statement or the iterator, when the condition becomes true, then we will break and return the index. So in this case we start iterating. First of all, i's value is 0, then i's value here the target value is 7, which is less than or equals to 1. So the condition becomes false. So I will increment it. It will be 1 now. Now the value will increment, value will be 2. So it is also not 2. Now we will replace it by 3. Here it will be, here it will be 6. Now here I will go 4. Here I go 9. So 9 is greater than or equals to 7. So it will return the value of I. So at the end the answer is 4. Now suppose our target value is 9. So what we will do, we will do this again, loop this again. At the start I equals to 0, then I is less than target which is 9 is less than or equals to I which is 0. Now I will increment it by 1. Here it will be 2. Here again 3. Here it will be 6. Here at 4. Here it is 9. So here also condition becomes true. 9 is equals to 9. So at this condition I will return 9. I will return 4 because 4 is the answer, which is the index. The I value will be returned. So this is the first approach which I am using, the linear search approach. So if we submit the solution, now if I submit the code for the linear search, it is submitted. Now let's check time complexity. It beats 69.72% of the submissions. Now let's discuss the binary search approach. What we will do the simple binary search. For binary search we must require 3 variables: L, R and mid. So these 3 variables we require. L for the left bound, R for the right bound, and mid for the searching index. So these 3 variables we required for binary search. Now let's consider this as an array. What we have to do is we have to do binary search on this. For binary search we must require one condition to be satisfied. The condition is the array should be sorted. Now if this is 7 is a target value in this case also, so how we will find the 7? First of all, 7 does not exist in the array, so we will first take an example in which the number or the target value exists in the solution. So in this case I will take 6. Now first of all I have to initialize 3 variables, L, R and mid. So for this I am using this array. L equals to 0, r equals to the size of array minus 1. So the size of array will be 1 2 3 4 5 6 7 8 9 10 11. 11 minus 1, 10. What will be the mid? There are mainly two formulas for calculating the mid. First one is L plus R divided by 2, which we are going to use. So this is the first formula for calculating the mid, and there is one more formula to calculate the mid which we does not require to use in this searching. Now for this, L plus R divided by 2, mid will be equals to 5. Now what we will do that if the mid value, suppose in this case mid is 5, we will put it here. In this case mid is 5. We will go to the fifth index, which is 0th index, 1st, 2, 3, 4th. So fourth index is 9. Now we will check that if mid is less than, first of all we will check if mid is equals to target value, then we will return I. If it is not, now we know that if target value is not equals to mid, then what we will do, we will increment, or we will first check that mid, if mid is less than t. Suppose in the first example, if mid is less than t, means the mid value is less than the target value. So if target is greater, then what we will do, we will increment L. We will increment L equals to mid plus 1. So this is the first condition, if mid is less than t. Now if we will check that if mid is greater than t, then what we will do, we will replace R, or we will decrement R by mid minus 1. So this is the second condition which we will check. And then at the end, if we does not find the value t, we will return simply L for the iteration or for the answer. Now we will iterate this for whole of this array, and then we will try to find out 6. So we just have to iterate over these values L, R and mid, and then we will check that if it is equal or not. Now first at 0th case, L equals to 0, R equals to 10, mid equals to 5. So at 5, I is 9, so it is less than. So what we will do, we will decrement R by mid minus 1, so it will be 4. So 4, and what will be the value of mid? Mid will be 2 again. Now we will check if 2, 0, 1, 2. If 2th index is greater than or less, first of all we will check equals to. If it is not equals to 6, then we will increment L by mid plus 1, so it will be 3. Now we will again find 3 plus 4, 7. 7 divided by 2 equals to 3.5, but it is, sorry, but we will take integer value, so mid will be equals to 3. Now we will check at third index. The value will equals to 6, so we will return I equals to 3. In this case we have result equals to 3. So this is what binary search do. Now we will check for 7. So for 7, first of all, L will be equals to 0, R will be equals to 10, and mid will be equals to 5. So at this, the value is 9. So we will decrement R by 5, and what will be the mid? Mid will be equals to 2. So at 2, it is greater than, so at second index I equals to 3, so it is less than 3, so sorry, it is less than 7. So what we will do, we will replace L by mid plus 1, it will be 3. Now let's check for 7. What will be the value of R? What will the value of L? So now let's check for 7. So what will be L? L will be equals to 0, R will be equals to 10, and mid will be equals to 5. Now what we will do, we will check that at mid index what is the value. Value is 9, which is greater than the target value. So what we will do, we will decrement R by 5 minus 1, which will be 4. Now what we will do, we will again find out the mid. What will be the mid? Mid will be 2. So now we will check on second index. Second index is 3. So 3 is less than or equals to, now we will check for 3. What is the, now we will check at second index what is the value at second index. So at second index the value is 3. 3 is less than 7. So what we will do, we will increment L by mid plus 1, which will be 3. Now we will again find out the mid. Mid will be 3. 3 plus 4, 7. 7 divided by 2, 3.5. We will take integer value, which is 3. Now what we will check, we will check at 6th index. 6th index it is 6. Now what we will do, we will check at third index what is the value. So value is 6. Now 6 is less than 7, so we will increment L. L will be 4. Now we will find out the mid. Mid is 4. So at fourth index we will check R will be equals to 3. Now we will check the main condition, which is, the main condition is if L is less, if L is greater than R or L is less than or equals to R, then only the loop will run. Now the condition become false, so the program will be break and terminate, and we will return the value of L. So now let's see the code. So the code is this. So in this, what is the code? We have first increment, we have initialized L, then R, then we have initialized the mid value by 0. Here we have find out the mid using second formula. So here we have find out the mid using second formula, and then here I have checked the first condition. If it is true, then I have written the value. If it is less than, then I have decremented the L, and if it is greater than, then I have incremented R. So at the end I have incremented L. Now if we submit the solution, and we check time complexity, so it is slower than the linear search. Why it is slower than the linear search? This is the main question. So many of the people thinks that if linear search can be applied on a array, then binary search will be more efficient to that thing, but it is not true. Binary search is always not that much efficient as linear search. In this case, why it is not as efficient? Because suppose in the linear search we will find the value by 6th index. By 4 searching, by 4th loop we will find the value, whereas using binary search we required 5 steps. Thank you guys. For more such content, like, share, comment, and don't forget to subscribe.